In this training, we're going to be talking about branch circuit device breaker sizing in ElectroBIM. So when I say branch circuit devices, we're specifically talking about all the stuff that has loads on it. Receptacles, light fixtures, equipment, motors, not panels, not transformers. We refer to those as distribution equipment. So we size things a little bit differently between distribution equipment and branch circuit devices. We're going to be looking at branch circuit device breaker sizing. There are a couple of different ways that we can size your branch circuits, and we're going to go over all of those in this training. The default is always to size based upon 125% of the connected load. So if you connect a receptacle or a light fixture or a motor, we're going to take a look at that load. We're going to give you a breaker that is 125% of that load. What are situations where 125% of the connected load on a circuit breaker is not right? So there are reasons why that 125% are not going to work. And so we have a number of features in ElectroBIM to account for this. And really there's three commands of note. We have instance edit, we have family edit, which I'd have to open up a family to see. And then we also have the circuit edit command. So we've got instance edit, circuit edit, and I'll go ahead and open up a family here. And if we look at a family, we have the family edit command. And those are the three places where you can give ElectroBIM more information about how to size your breakers so that they come in correctly. And I would generally recommend that you think through the sizing of your breakers in that order. First, try and do it with instance edit, then think about doing it with family edit, and finally do it in circuit edit if necessary. So let's take a look at what those commands do. If I go over here to this view, we've got this cooling tower here. So if I select this cooling tower and I run instance edit, it opens up this window here. And we have this OCP trip setting. And you can set this for each individual device. We have a number of different settings available for this. We can do it based upon NEC 440, which is for motor compressors. That's where we're sizing it based upon the MOCP. We can do it based upon NEC 430, where you're sizing it based upon the FLA for motors. You can also just give us the breaker size. So we have these two specific NEC code sections embedded in the software, and then we have the ability for you to override it. So if you have a specific device that has a specific breaker size that you need, you can specify it here. The reason that I recommend that you start here is because this is very, very easy. You can run instance edit, you can select the device, and you can make the change on it without having to go mess with families or anything else. It also puts the breaker size on the device itself rather than in the circuit. We can do this in circuit edit, but that's setting the value in the circuit, which is not really what's controlling that breaker size. The device is connected to the circuit, and so the circuit is going to have a larger breaker or a different size breaker. But it's not because of the circuit that it has a different size breaker. It's because of the thing that's connected to it. So if you go down to the thing that's connected to it and make your change here, it's going to document your design thought a lot better so that when you come back into the project 6 months later and you say, why is this breaker a different size? And you open up the instance, you say, that's right, because I'm sizing it because it's a motor. And then you'll remember that. Or if someone else is opening up, they have a little bit better idea of what's going on, as opposed to if you just set it in the circuit, you lose some of your design intent when you do that. So if at all possible, I would recommend you come in here and we can do it based upon the motor compressor. That's based upon MOCP and the branch circuit selections current. So if you specify this, you then actually need to specify your MOCP and your BCSC. So you set those values and then we will size based upon that. So in this case, I'm going to leave this as size automatically for a moment. If we run circuit edit, it's currently a 70 amp breaker. If we go to instance edit and we set it based upon MOCP, and we set the MOCP to 40 amps, we will see that it is now sized to 40 amps. So that's fairly straightforward. And the other settings work the same way. If we want to size it based upon FLA, we can do FLA, and then the MOCP is going to be ignored. And let's say the FLA is 40. And we're going to size based upon that. We're actually back up at 70 because of how that math works out. Instance edit works very well because it's easy and it's putting the information at the level that it belongs on the device itself. Where it doesn't work so well is if you have a lot of devices where you are doing this. Say we had multiple cooling towers and they were all defined the same. You could go in and you could modify them one at a time. You can actually select multiple and you could also run instance edit on it. So if I select multiple receptacles, you can, for example, run instance edit at this point, and it'll allow you to modify all 3 of those at the same time. So it's a little bit, it's possible to make the changes on all of them. But then if something happens and you need to address it on all of them in the future, you have to go back and change them all individually. So if you have something that's fundamental to the device that you're going to be using more than once in a project, that's where the family edit comes in. This is where you say, okay, I've got this cooling tower, and rather than going into each individual instance, I'm going to go into the cooling tower family itself, run edit family, and then I'm going to do family edit. Now here we can specify for each type the settings. So we're going to first say that this is an equipment connection, which gives us a couple more options. And then we can actually specify all of these values, FLA, MCA, MOCP, and how the breaker and conductor are sized. So now we can say, okay, for this type, we are always going to do this based upon MOCP. And then the MOCP we're going to specify is always 40 amps for this piece of equipment. And then we can have that based upon the type. You could also have that based upon a parameter if you want to input it that way. So you got a couple options for getting that MOCP, but now your breaker is always going to be sized based upon that MOCP value for all instances of this in the project. Once you've made the change in the family, then you can load the family into the project, save it out as a family to use in future projects. So that's kind of, managing your families at that point. But this way we have a family that's set up so that it's going to size that breaker automatically for us. And that way we don't have to set it at the instance level. Then the last place to look is in circuit edit itself. Now, if you are working on this, you can always run circuit edit and you can hunt down your panel and then you can hunt down your breaker and you can set the value here. So we can, for any circuit, just give it a value for the breaker size. And this is where you're saying, I'm not sizing it automatically. I know what size breaker I want. It's not really based upon the device. I want to do it at the circuit level. And you can do that here. So if you have an instance where setting it at the instance level doesn't make sense, you can just set it at the circuit level. Finding the circuit, there's a bit of digging. If you got a lot of panels in your project, it can be a little tedious to hunt down the circuit to make the change in. In that case, what I recommend is if you select a device and you run circuit edit, it'll open up the circuit edit with that circuit selected. That makes it a little bit simpler to actually go find the circuit and then make the change. So now I know, okay, I'm on PP1A, I'm on circuit 6, and I can directly set my breaker size here. So that saves you hunting that down through RUI. You just find it on the floor plan, you select the device, you run circuit edit, and it'll pull up that circuit for you.